right. So we solved this problem last time. We saw that if we know the grams that there are per mole of carbon dioxide, and we start with 1.55 grams, the way to set this up is we start with what we know, 1.55 moles, sorry, of carbon dioxide, and we're going to want to identify how many grams of carbon dioxide that is. And we can use our conversion factor here, converting from moles of carbon dioxide to grams of carbon dioxide. I put in the correct values, 44 grams for every 1 mole, and that gives me my answer, number of moles that I'm after, right? Okay, now, how about this? How many moles of carbon dioxide do I have if I have 10 grams of carbon dioxide?
10 grams?
Yeah,
Well, that's not a mole.
that's right. I'm not going to have a full mole, but I can have a fraction of a mole, right? I can use my decimal places and so forth, right?
Oh, okay, yeah.
All right, so how do I do this one?
Just divide?
Well, that's not a very effective answer, just divide, right? What we need to use is our,
Oh, yeah, our dimensional analysis.
that's right, we use our dimensional analysis because that's the tool that will help us answer questions that we don't know how to answer, right? So we start off with what? What goes to the right of our equal sign?
Oh, you want moles.
That's right, I want moles of carbon dioxide. And then I start off with what?
Grams of carbon dioxide?
That's right. So I have 10 grams of carbon dioxide. So they told me 10 grams, I want moles, and now I can use my conversion factor here and go from grams of carbon dioxide to moles of carbon dioxide. All right, and there's that 44.01 grams for every 1 mole. So 10 divided by our 44, all right, that's going to be our 0.227, and really just one significant figure here, so about 0.2 moles of carbon dioxide. All right, now again, you need to divide, but setting up your unit analysis is what we really want to do. All right, so here's one for you at home. Everybody try this one at home. Identify what mass in grams would you need of this material to get 3.2 mole sample of it. All right, everybody take your time at home. Push pause, figure out the answer. All right, Fred, tell us what you think.
What does that mm mean?
That's a good question. What do you think?
Oh, I don't know.
That stands for the molar mass of this compound.
Oh, that's nice.
That is nice, so I don't have to add them up. I know that it's 310.2. And what are the units for the molar mass?
That's how many grams you have to get a mole.
That's right. So this is grams per mole. So I'm going to write that down here because that's a helpful conversion factor. That there's 310.2 grams of the, what is the name of this compound, Fred?
That's calcium and phosphate?
That's right, calcium phosphate. All right, 310.2 grams of calcium phosphate for every mole of the calcium phosphate.
Then what?
Well, what do I want to the right of my equal sign? What units am I after?
Mass in grams.
That's right, I want grams of calcium phosphate. All right. And I start with what?
Moles.
Yeah, I start with 3.2 moles. If I have 3.2 moles, I'm wondering how many grams that'll be. So 3.2 moles of the calcium phosphate. How many grams is that going to be? So I'm going to use this conversion factor, but I need moles on the bottom, right? Moles of calcium phosphate. And grams of calcium phosphate up top. So that's where my 310.2 goes, and that's 1 mole. So 3.2 times the 310 will give me my answer. All right, so so 992. Is 992 up there?
I think that's what B is, right?
That's right. 9.9 times 10 to the 2 is 990, and the units are grams. Good. All right. So this brings up or helps us recognize the importance of what we call stoichiometry. Stoichiometry. And I can make statements about my number of moles of my different components that I have, either within a given compound, within a chemical equation, or any sort of scenario where there's different materials, that different amount of material that relates to each other. So for example, if I have a mole of sodium carbonate, in that mole of sodium carbonate, I have 2 moles of sodium. Does that make sense?
I'm not sure.
Well, so for every mole of sodium carbonate, if I have 1 mole of Na2CO3, how many moles of sodium are there in there?
There's more than one?
There is more than one, because for this 1 mole, I have every mole of this, every unit of this, there's 2 sodiums, 1 carbon, and 3 oxygens. So there's 2 moles of sodium for every 1 mole of sodium carbonate. You see that?
Yeah, I think I see it.
Okay. Now, a lot of people are bothered by that. How can you get 2 moles of sodium if you start with just 1 mole of material? Well, it's like cookies. Here's a cookie, chocolate chip cookies, right? And I have 1 cookie, and I can break this cookie up into cookies and chocolate chips, right? So for every chocolate chip cookie, there's 1 cookie and 4 chocolate chips. 1 of these, it breaks down into 1 of these and 4 of these. And we don't complain and say, wait, how did you get all of a sudden 5 different things out of 1 thing, right? Here I have 1 thing, it's a sodium carbonate unit, but it can break down and I'm going to get 2 of those sodiums out, okay? So it's possible to get more moles of different things out from your combination, right? So don't get confused or concerned about that, right? And so I can make lots of stoichiometric statements. 1 mole of carbon for every 1 mole of sodium carbonate. 3 moles of oxygen for every 1 mole of sodium carbonate, okay? We can use these on the atomic scale as well. There's 1 atom of carbon for every formula unit of sodium carbonate, all right? So there's lots of different stoichiometric statements that we can make. So here's a question. Calculate the number of moles of sodium in 2.53 moles of sodium carbonate. How many moles of sodium in 2.53 moles of sodium carbonate? All right. What goes to the right of my equal sign, Fred?
You're trying to find moles of sodium?
Very good. So I'm trying to find moles of sodium. So I'm going to write moles of sodium to the right of my equal sign. What did they give me to start with?
2.53 moles of sodium carbonate.
Very good. 2.53 moles of sodium carbonate. Now, here's where it becomes important, as we studied in the last chapter, how to identify what sodium carbonate is. Because if I say sodium carbonate is NaC, then the number of moles is going to be different than if I say it's Na2CO3, or if I say it's Na3CO3, right? If I don't know what sodium carbonate is, I'm stuck, right? So, do you remember which one it is?
It's Na2CO3.
Very good. So this is 2.53 moles of sodium carbonate, Na2CO3, and I want to go from moles of sodium carbonate, Na2CO3, to moles of sodium. How many moles of sodium are there for every mole of sodium carbonate, Fred?
That's the 2, right?
That's right. There's 2 moles of sodium for every 1 mole of sodium carbonate. So 2.53 times 2, that will be our answer of how many moles of sodium I can get from 2.53 moles of sodium carbonate. Now we can further calculate the atoms of sodium that are in the 2.53 moles of sodium carbonate. All right, I can do that one right below here. This time, instead of moles of sodium, what am I after?
It says atoms of sodium.
That's right, atoms of sodium. Okay, atoms of sodium, and I'm starting with, again, the 2.53 moles of sodium carbonate. But I can go from moles of sodium carbonate. Now I know I needed sodium carbonate down here because I need to get rid of those units. I need to get into atoms of sodium. Do you know how many atoms there are per every mole of sodium carbonate?
I think I do, but it's kind of confusing.
Yeah, it is because what we should know is if I have a mole of something, how many of those somethings I have. That's the 6.02 times 10 to the 23rd. But if I want to know how many somethings I have for every mole of some complex compound like this, it's a little more confusing. And so what we do is we just keep it simple and say I can go from moles of sodium carbonate to every mole of sodium. And then I can go from moles of sodium to atoms of sodium. Find how many sodium atoms would there be in that many moles of sodium carbonate. Okay? And this here is for every 1 mole, I have that 6.02 times 10 to the 23rd atoms of sodium.
Okay.
So then I can line them up and I can multiply them out and find that answer. Let me show you how to do this in your calculator because it's very important that you put in large numbers like 6.02 times 10 to the 23rd into your calculator the correct way. So I got 2.53 times 2 times, now watch how I put this one in. Whoops, we got to turn it sideways so you can see very well. I go 6.0223 times 10 to the 23. And if you do it that way, then that will give you the correct order of operations, and I can push enter and I can get the right answer. And it's expressed in scientific notation, 3.05 times 10 to the 24th atoms of sodium for every 2.53 moles of our sodium carbonate. Okay, good stuff.